Okay, Adam, you took your quiz that you had missed. Charlie, you're all done. Nilakshi, you're all done. So we are all caught up in this class. Excellent. Okay, so here we want, for example 5, it's asking us, does the point -2, 1 lie inside, outside, or on the circle with this specific equation, x squared plus y plus 6 squared equals 23. Now, you all remember an equation of a circle is x minus h squared plus y minus k squared equals the radius squared. Now, we know HK represents the center, R is the radius. Who remembers what X and Y represent? So HK is the center, R is the radius. What do X and Y represent?
The center point.
Nope, HK represents the center point.
X, Y. All the points.
James, give him a second. All right,
Oh,
X,
I thought you were moving on to someone else.
No, we were giving him a second. It's okay though. X, Y represents all the points that exist on that rim of the circle. Okay. So now when they're asking, does this random point, -2, 1, is it going to be on the rim of the circle? Will it end up outside the circle? Will it end up inside the circle? The way you're going to figure that out is you're going to take your general equation of the circle, which is x minus h squared plus y minus k squared. If it equals r squared, once you plug everything in, it will be on the circle, on the rim of the circle. But let's say we plug in x and y, and we have x minus h squared plus y minus k squared is greater than r squared. Then we are going to end up outside the circle. And the last one is if we plug in for x and y and we end up with x minus h squared plus y minus k squared is less than the radius squared, we are going to end up inside the circle. All right, so the specific equation they're giving us is the equation x squared plus the quantity of y plus 6 squared equals 23. So now I'm going to take the point. What was the point they wanted us to test? -2, 1. And I'm going to substitute it in for xy. So now when I substitute in, I'm going to substitute -2 in for x, so we are -2 squared plus the quantity of, instead of y, what am I going to substitute in? 1, good. 1 plus 6 squared. And I want to know what's that relationship to 23. So I went to the equation of the circle they gave me. I substituted the coordinate for x and y, and now I'm going to simplify the left side. So we are 4 plus 1 plus 6 is 7 squared, right? Do we agree at this point right now, we know 4 plus 7 squared will be greater than 23? So at this point, we already know this. We don't have to keep going. So we know since the left side is greater than the radius squared, we are going to be outside the circle. All right, just need to show you one more problem. We ready? Anybody still copying? All right, so now we're on example 6. Now, I should have given extra information for the circle below. Let's call this center point O. So we're going to call this circle O. So then we know that point 3, 4 is the center. If I didn't identify that, we wouldn't know what the center was. We'll go step by step. The first thing they want us to do is find the radius. Where do you think the most strategic place is to draw this radius? From what to what? Chase?
3, 4 to 6, 8.
You got it. From 3, 4 to 6, 8. How come that was the best place to draw the radius? Why? I could have just drawn it across here. Why was from 3, 4 to 6, 8 the best place? Connor?
Because that's designated point.
Good, because it's a point with coordinates. And if I have 2 points and I have their coordinates, what can I find between them using a formula? Their distance. So I'm going to now find the distance between them. And if you all remember, the distance formula tells us d, the distance between 2 points, is equal to the root of x2 minus x, the quantity of x2 minus x1 squared, plus the quantity of y2 minus y1 squared. It does not matter which points you designate as x1, y1 and which points you designate as x2, y2. So I will take 3, 4 and I will call it x1, y1. And I will take 6, 8 and I will call it x2, y2. And now I'm going to substitute those values in. So we are going to have 6 minus 3, that quantity squared, plus 8 minus 4, that quantity squared, and then we take the square root of all that. So we are left with 3 squared, the root of 3 squared, plus 4 squared. So d will equal the root of 9 plus 16, which is square root of 25. What is the root of 25? 5. What does this mean?
The radius is 5.
The radius is 5. So for part A, this was all part A, we have radius is equal to 5. All right, so we figured out part A. Now, I'm just going to ask you this question, even though it's not a question in here, just for fun, because this is so much fun. Tell me, what would be the equation of the circle? What would be the equation of this specific circle? We have the center point and we know the radius. If you have the center and you know the radius, you know the equation of the circle. Like an equation of a line is y equals mx plus b. I need the equation of this circle. Yep.
All right. X minus 3 squared plus y minus 4 squared equals 5 squared.
Yay. Okay, guys, remember, the quantity of x minus h squared plus the quantity of y minus k squared equals the radius squared. That is the equation of a circle. All you need is the center and the radius. The minute you have a center and a radius, you can always write an equation of a circle. So we just simplify this a little bit more. The quantity of x minus 3 squared plus the quantity of y minus 4 squared will equal 25. That is the equation of this circle. All right, so we did part A. We sidetracked a little bit. And now let's go on to part B. So for part B, we're asked to find the distance from the outside point to the center. So what they want us to do is this point 10, 2. We want to find the distance from 10, 2 to 3, 4, the center point. Well, can I just use the distance formula again? Right, so now I'm going to say D2, since I already, or D1, I'll say D1, since I already used D, is equal to the root. Now, I already have x2, y2. I already have x1, y1. So I'll call 10, 2. I'll call 10, 2 x3, y3. Because I've already used x1, y1, and x2, y2. So now this distance will be x3 minus x1 squared plus the quantity of y3 minus y1 squared, all under the radical. So now we substitute in. So I'm going to have 10 minus 3, that quantity squared, plus 2 minus 4, that quantity squared, all under the radical. So we are down to the root of 7 squared plus negative 2 squared. So we are 49 plus 4. So D1 will equal the root of 53. Can I simplify the root of 53? No, we cannot simplify the root of 53. So we leave it just like that. So that means from O to 10⁻² is the root of 53. All right, there is one more part of this problem. We want to find the distance for the outside point to the circle. A lot of students do this. They want 10⁻² to 6/8 and they use the distance formula. We don't want that. When they say the distance from anything to anything else, they want the shortest distance. So the shortest distance will just be a straight path, like there. So that's the distance we want right now. I can't use the distance formula because I don't have the coordinates of this point right here. So does anybody know how we can find the distance from 10⁻² to the rim? Bridget?
25 minus root 53.
Say it one more time.
25 minus root 53.
Why 25?
This is the radius.
The radius squared is 25.
Oh, I mean 5.
So then if this is 5, Bridget's right, that's going to be the radius. So from O to the rim is 5. But then you want to do not small minus big. You want to do big minus small. So we are going to do root 53 minus 5. And that is our distance from the outside point to the rim of the circle. Alrighty, so what I want you guys to do now, I can stop recording.